Okay, so up to this point, why don't you give me some names of some enzymes we've discussed in class? Don't need to say how they've been made or where they're found. What are some examples of some enzymes? Amylase, lipase. I gotta get closer because I can't hear you. Sorry. Okay. Okay. And there's two more. You might have said it. What's one? No, that's we're not looking for that complex. I believe what you're saying. Yes, because one's initiated in the stomach, probably the most important one, and maybe you said it, but I didn't hear it. Pepsin. Okay. And pepsin's the most common one of these, but what's a lesser common enzyme that also does the same function as pepsin? Enterokinase. Yes. We're having problems with what? Okay. Oh, okay. All right. So, with that, then, okay, where, then we try to name these enzymes and where they're coming from, whether it's the amylase is found in two different spots. Of course, your mouth from saliva glands and also from your pancreas. And then we have lipase again that breaks down different fat molecules. So we have three different enzymes that have three totally different functions. Okay, and actually there's one more we could talk about. That's breaking down nucleic acids into individual nucleotides. Those are nucleases, like you had mentioned earlier. So our three main enzymes are amylase. They come again from your mouth or saliva glands, your pancreas in the form of pancreatic amylase. Then we also have pepsin and enterokinase that break down proteins, and then we also have pancreatic lipase that breaks down fat molecules. Okay, so we began talking about that of the liver. So what are some really important functions of the liver that we just briefly mentioned? Has something to do with proteins. Break down proteins. Okay, it does that too. Yeah, that's the metabolism of proteins, that's right. And probably as far as a detoxification effect, probably the most important one is that of breaking down uric acid to what? To urea. That's right. Okay. And then the lesser known one is those clotting factors that the liver also produces as well. So those three functions. Okay. So again, one of them is this protein metabolism. Okay. So you might be wondering, well, why is that important? Well, the liver is also going to aid in breaking down and being able to absorb, okay, these proteins adequately. So, because remember, metabolism is a balance of what we call anabolism, which is building up of molecules, and catabolism, which is breaking them down. So a balance of building up and breaking down gives you your specific metabolism, because no two people have the same type of metabolism. They may have similar ones, but they're not going to be the exact same. So the liver aids in that, and it breaks down uric acid, as we can see, to urea. And then finally, it makes clotting factors for inside of our blood. Okay, and those types of cells are called what in our blood? Well, I mean, I said that wrong. Sorry. I need to start over. Okay, clotting factors are not platelets. Okay, clotting factors are proteins like fibrin and thrombin. It's those types of clotting factors that arrive at the scene. You could call it the scene of a wound. And what that fibrin does, just picture like what fibers do, is they would wrap themselves around in a mesh. Okay? Now, you can't see this happening. The scar is the end result. Okay? So what you see happening is this fibrin uh, wraps itself around the site of maybe a scab on your elbow. Eventually what that fibrin's going to do is that's down, it's pulling that closer, closer, and closer together until the two sides of the wound eventually come and lock themselves together. Then your scab falls off. There's a difference between a scab and a scar. If you keep picking at it, I think we're all guilty of that. You're already laughing that some people, they pick at them, then that's what leaves the scar. Yeah, sometimes it's like trying to hold back the wind. Yep, I get it. Okay, so then we move on. Okay. Glycogen. Okay. That, okay, is a very large carbohydrate, which then gets broken down into glucose molecules. And notice we really do not have one fix-all, what do I want to say, uh, I don't want to say detoxifying, but removing these damaged red blood cells. For the most part, we have a separate gland that does that for us. It's not necessarily the liver, okay? And it sits perhaps just a little bit below or inferior to your heart. And it's very susceptible to people in automobile accidents because it's where the track of that seatbelt is as it goes across your thoracic cavity. Does anyone want to maybe take a guess what that would be about right here? The what? Starts with an S. Rhymes with doing this up against a wall. You might lean up against the spleen. Yep, your spleen is responsible for that. So again, there's really no fix-all for that. The spleen will remove them as well, but then you also have your liver that takes care of that as well. And a biochemical aspect of what we see here, detoxifying your blood, okay? Whether it's from caffeine or from alcohol, what's happening is your liver starts placing lots and lots of OH molecules on there. That makes them water soluble then. So then that substance then can be removed from the blood because in the kidneys because it's water soluble. Because some people maybe drink lots of soda / pop. Some people don't drink any at all. So for argument's sake, we're saying you drink a lot of pop. Doesn't matter whether it is or whether it isn't. What happens when you drink a lot of pop? You're on some people maybe drink 3 or 4 cans a day. We're just making that up. Chances are, once they make the transition, if they're close together, in other words, one lasts them about 2 hours, then they have another one, and another one, and then another one. What's starting to build up in their blood besides sugar? They caffeine. Your body has to have a way of removing that. So what happens is the liver takes care of that for us, and then it's been filtered out of our blood from the kidneys, and then that is then sent to your bladder and eventually removed from the body. Okay, the small intestine, we know that there's three parts to it. You either say the duodenum or duodenum. Okay, the junction of that from the stomach to the duodenum, there's an opening there. What is that opening called? Correct. Pyloric sphincter. That's right. Or pyloric opening. Okay. And then, again, the duodenum is the first. Then the duodenum, as you can see, is the second. And then the third portion starts with an I. And it's the ileum. And that also has a valve in it. And why is it called the ileocecal valve? Does anyone think they might know? That's correct. Yes. Sometimes what can happen is if maybe some individual is doing some sort of physical activity, they perhaps lift something too heavy for their back and does some damage to their back. They herniate a disc. Maybe you've heard of that before. If someone herniates one of their vertebral discs, does anyone think they know what's happening between your vertebrae? Because your vertebrae do not come in contact with one another. Okay? There's a gap in between there. What might that gap be? What substance? You know, some of you people do one of these things and crack, 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 crack. Turn this way, crack, crack, or lean back over your chair like this. Or it's very similar to this. Okay? So what's happening inside these joints? What's in there? It's not skin. It's not muscle. It's not bone. It starts with this. C. Cartilage. That's right. And what happens, you have synovial fluid in there and water packets, and when you do that, it's that popping noise. That's what you hear. There used to be some people saying, don't crack your knuckles, your joints are going to maybe swell up, or now whether that happens or not, just depends who you want to ask. So the same thing happens with that of the vertebrae. That's what you actually have happening, and people may know or feel that, oh, my back is sore. So you might say, geez, come crack my back. So some people, they maybe lay on the floor, or maybe someone grabs them from behind, give them a lift up, and then a quick pull inwards, and then sometimes you hear that popping. And what can happen is maybe it's putting that vertebral disc back into place. Not likely, because if you have a slipped disc, you're probably in too much pain to have something like that happen. Some need to be surgically corrected, but the reason we mention that is also if you try to lift something too heavy and you jar your abdomen, okay, do you remember it was one of your vocab terms, your lumen of your small intestine is held in place. But if you put too much stress on there and you do a certain jolt, it can pop your intestines out of place. Sometimes I think, how many of you have seen the sad, sad movie of Marley and Me? You ever heard of that? Okay, so you've nodded your head yes. Okay, so what happens to Marley towards the end he lays down, and as he's, I don't know if he's rolling around, but what happens, do you know, through the course of the movie? It's something with his abdomen. His intestines do what? They roll out of place, they twist, and rather than being like this, it does something like that. Okay? And sometimes I think that can happen in horses too. Okay? Colic, you say? Yep. And I sometimes wonder, can diet cause that? Not enough hay or water or something like that? Okay. Okay. So what happens then is if your intestines pop out of place, the tissue that holds them, maybe that rips and tears, and then your intestines may pop out. Like it's supposed to be sitting in here like this, but then all of a sudden it pops out of there and makes a kink. Now, the biggest problem with that is, yeah, food's not going to be making its way through there, but what's going to start building up inside your intestines? Toxins, poisons, because it's not moving through your digestive tract how it should. Okay, so you have your duodenum, first portion, duodenum, second portion, and then as you can see, your ileum. Okay? We have what looks like one more slide after this, and then that will do it for the chapter. And then we want to look at some diagrams for a brief moment, and then we will start that abdominal surgery. And it is pretty drastic. Before, in my opinion, how Discovery Channel has changed its format. Now you have, like on Monday nights, I think it's called, what, Fast and Loud, and maybe Tuesday nights still the Deadliest Catch. I don't know what Wednesday nights are. It used to be Mythbusters, either that or Thursday night. But they used to have different types of series on Discovery Channel. This one's called Surgery Saved My Life. And that's what it's actually called, an abdominal super surgery. And you're going to see why it's called that in just a few minutes. Okay. So here again we see that term amylase. It's talking about beginning in the mouth with saliva. But that's not the only place where we get amylase from. The other source is where? Nope, we already established that. It's within the mouth. Where's another source? Pancreas also secretes pancreatic amylase. Then finally, the last portion, okay, maybe this is already written in for you, maybe yes, maybe no, okay. Okay, so one thing we probably want to do, okay, let's take a peek at some of these. All right, we won't spend a whole lot of time on this, but are we done with this portion? Okay, I will shut this down for just a moment. All right, so what we want to look at is on page Okay, a very important diagram is on page 668. Okay, because remember we talked or ended the class yesterday, there are 4 different ducts from the liver and gallbladder into the small intestine. what are those ducts? What are the 4 ducts? Which one? Okay, a little more specific. Look at page 668, that'll tell you. Left and right hepatic ducts, so there's 2. The common hepatic duct. You have the cystic duct, and then I'm sorry, I maybe counted them both together yesterday. We actually have 5, okay? Notice where it says bile duct, that's also common bile duct. It means the same thing. So, yes, that is correct, okay? Notice, in one thing to keep in mind is the gallbladder is more so an organ, not necessarily a gland. Okay, you might be thinking, well, why is that? Well, typically we associate glands producing the substance that it secretes. We know that bile is stored in your gallbladder, but it's not produced in your gallbladder. It's just a storage tank, okay? Because where's bile actually produced? Not the gallbladder. It's produced where, do you think? It's actually in the liver, okay? So what we see happening then is when needed, you could say then the gallbladder squirts this material. We don't want to say secretes because it's not produced in the gallbladder. Remember learning that over 20 years ago, okay? And we'll start talking about memories next chapter when we start talking about the nervous system, but we were taught in the physiology class, and I believe this is accurate still to this day, the gallbladder is just an organ. It's not a gland because, again, it's not secreting a substance that's made there. Only the liver does that in this case. So you might be thinking, well, how does it get into there then? Well, you also notice that down in this magnification here, there's some smooth muscle that goes into the small intestine, and that smooth muscle actually constricts that, you could say, that sphincter there, okay? Hepatopancreatic sphincter. So if we have a hepatic artery and hepatic vein, the Latin word for liver is hepatic. That's why it's called that, okay? So when we look at this, if that stays shut, that sphincter stays shut like this, well then eventually what happens, okay, is the liver will secrete that bile then, and eventually once it gets towards the bottom here, if that's shut, it's eventually going to start moving back, and then once it overflows, it goes back into the gallbladder where it's stored, okay? So there's essentially bile stored in that tube, but it also goes all the way back up into that gallbladder, okay? So you're going to want to know these muscles, sphincter muscles, these ducts, the pancreatic duct, the left and right hepatic duct, the cystic duct, the common hepatic duct, and then also finally the common bile duct, okay? Then we see we got the pyloric sphincter, because that's where the stomach is sitting right about here, okay, about where my hand is. That opens up, and then that goes into this first portion of the small intestine, or known as what? The first portion is the duodenum, or you want to pronounce that. So very important diagram on page 668, okay? Then we also want you to know on page 662, okay, we see figure 17.17 or 1717, the stomach there. You have the term body is going to be a repeating term throughout the course of human anatomy, whether it's the body of the stomach, the body of your sternum, the body of your vertebrae, that's used in a variety of ways. So we want you to know the esophagus, the cardiac. We don't want to know it as lower esophageal sphincter. We want that the cardiac sphincter. Okay. So esophagus, cardiac sphincter, fundus. Okay. The body, the greater and lesser curvature. Okay. And the gastric folds, where the gastric pits would be, okay, the pyloric opening, the duodenum or duodenum, okay. So those are all terms that we want you to be able to identify, okay. So 662 and 668 are very important diagrams that you're going to want to know. I went through that very fast. We'll come back to that again tomorrow and probably next week on Monday. Your papers are due on Tuesday, where we'll start reviewing. I did say the 19th. Okay. So we'll have them due on Wednesday. We will start reviewing on Tuesday and Wednesday. And then it'll be a two-part exam on Thursday and Friday. So depending upon how you want to do that, if you remember from physical science, okay, do you remember the difference between part 1 and part 2? Part 2 was always what? Story problems or problem solving. Part 1 was just general questions and vocab. We can flip-flop these next week. Part 2 is what we just went over with those diagram identifications and essay questions like the how's pepsin created. Like I said, when you look at them two slides, you want to star, underline, whatever it is you need to do to make sure you can describe how pepsin is made. Okay? And we also want you to be able to know the functions of the liver. We'll go into that again next week. Okay? Did we go too fast? Is there anything you want me to repeat? Okay? We'll go over what it is you need to know. That would be part 2. Part 2 is, again, the diagrams we just went over, and probably some essay formats. The pepsin mechanism, the functions of the liver are two big things we really want to be able to describe. Okay? And notice that's when we start each day, we say, okay, so how is pepsin made? And that's why we want you to be able to go through and say, okay, when food enters the stomach, you have your parietal cells secreting what? Hydrochloric acid, or just acid, it's fine. Then your chief cells are secreting specifically an inactive form of pepsinogen. Okay? The pepsinogen comes in contact with the acid. It activates the pepsinogen to pepsin, so then breakdown of what can take place in the intestine. Proteins, okay? And then there are two hormones inside the stomach. One turns the tap on for, actually I'm turning it the wrong way. Typically you turn it to the left to turn it on, I think. Turn the tap on, and that's which hormone? Starts with a G. Gas something. Gastrin. Gastrin's the hormone, but the hormone that turns the tap off, that's a really long word and it's kind of difficult to say. Cholestokinins. Now, that may seem like it's overwhelming, but that's why we go over it and over it and over it. Questions? If not, I'm going to go ahead and start the video. If you're feeling overwhelmed, don't worry. It's not the last time that we're going to be discussing this. Okay. So go ahead and get this going. And continue this again tomorrow.
want them